Hey grade 8s, so welcome to your Wednesday math lesson. So as I mentioned in the last lesson, we were kind of coming to the end of our unit on integers. So we did addition, subtraction, multiplication, division, word problems, and order of operations. For this next for this next mini unit, which should only take about 2 or 3 lessons hopefully, is going to be based off of algebra and using integers and fractions as part of an algebraic expression or an algebraic problem. So for this lesson today is going to be mainly a review from last term that you would have done with Mrs. Stevenson way back when. So we're going to do a little bit of a review, and then the next lesson we should be able to go into using integers and fractions in an algebraic problem. So I think we're going to do integers first in algebraic problem because it's so fresh in your minds, but also using integers in algebraic problem is actually quite simple, especially once you know the rules for integers. And then we're going to go into fractions. So for this first part is a bit of a review. So the problem that we're using is on this slide here is the cost, C, in dollars of a pizza with n toppings is represented by the equation cost equals 2 times the number of toppings plus 5. So we're looking at which of these statements is true. So let's look at the numbers in our problem, is 2 and 5. So 2n and 5. So look at the way these answers are written. The base cost of the pizza is $2 and the cost per topping is $5. So the number of toppings you get will be depending on how much. So if each topping costs $3, for example, it's not actually $3, but it was $3 per topping. And let's say I wanted to get 4 toppings on my pizza. It'd be 3 times 4 because it's $3 times 4 different toppings that I'm getting. So which part of this expression has multiplication in it? It's 2n because $2 would stay the same. That's not going to change because a topping is going to cost $2. It's always going to cost $2 no matter what the topping is. However, the number of toppings I can get will change because maybe I'm getting 5 different pizzas and one of the pizzas has 1 topping, another has 3 toppings, another one only has 2 toppings. That can change. The other part of this problem is the plus 5. So in the algebraic problem, when you have that plus 5 tagged onto the end, that number will not change. It'll always be that $5. So if I've already figured out what the toppings are, that $5 must be the cost of the pizza itself. So if I were to get a pizza, it would cost me, if I was just to get a plain cheese pizza, for example, it would cost me $5. But it would cost me $2 per topping. So it would be 2 times the number of toppings that I get. And that's what can change in my algebraic problem. So which of these statements would be true? The base cost of the pizza is $2 and the cost per topping is $5. Well, that can't be true because the base cost of the pizza isn't going to be multiplied by anything. I'm not multiplying the pizza by the cost of the base pizza times the number of toppings. The base cost of the pizza is an add-on, as in it's added on to the end, but it's not being multiplied by anything. So that can't be true. The base cost of the pizza is $5, so that would be the plus 5 of our equation right here, and the cost per topping is $2. Well, that makes sense because I have a 2 right here, and I have a 5, and it would be 2 times the number of toppings I decide to get. So let's say on Monday, I go get pizza, and I decide I want 3 toppings. It would be 2 times 3 for the number of toppings I want, plus the $5 for the pizza itself. But next month I decide I want to get only 2 toppings. It would be $2 times the number of toppings, which is 2, plus that $5 for that pizza. So in this case, the answer is B. because that represents my equation of the $5 is the base cost of the pizza and $2 is the cost of the toppings times how many toppings I decide to get. So that's our little bit of a review question. The next part we have here is, you plan on joining an online movie club. You have two membership options. Option A is $2 per movie and a $30 fee to join, or option B, $4 per movie and a $10 fee to join. Which is the better option? Why? Create a table, graph, and an equation. So let's break this down. Option A is $2 per movie and a $30 fee to join. So if I were to represent this as an equation, is you're not helping me. If I were to represent it as an equation, it was $2 per movie and $30 to join. So that $30 to join is on its own, because that $30 to join isn't going to be contingent on how many movies I go to watch. If I go to watch 100 movies or if I only go to watch 2 movies, it's still going to be $30 no matter what. Whereas the number of movies I go to watch will vary. So $2 per movie. So if it's $2 per movie and I have to multiply by the normal number of movies I can choose to go see. So I would put it as 2 times n, or 2n, because it's $2 times the number of movies I choose to watch. So n is the number of movies I choose to watch, because I can plug any number into that n spot. I can plug in 5, I can plug in 10, I can plug in 50. It doesn't matter. So if I were to create an expression, C would equal the cost, so cost of the membership. 2n is the $2 per movie, so $2, and n is the number of movies I can choose to watch, plus 30. And I only add the 30 because that 30 will not change. That 30 is always going to be there because I have to pay that $30 fee to have a movie pass. The next option, option B, is $4 per movie and a $10 fee to join. So the $10 fee to join, that stays on its own because it's always just going to be $10. And in this case, it's $4 per movie, and it'll be multiplied by the number of movies I choose to see. So it'll be 4n. So 4n plus 10. So $4 times the number of movies I choose to go watch plus the $10 fee to join. So those are my two expressions. Which one is the better cost? There's one way I can do it is take a number. Let's say I want to go watch 20 movies. Then I can plug in the number of 20 for the number of movies I want to go see and see which one gives me the better value. So in this case, option A is 2 times the number of movies. So in this case, I want to watch, did I say 10 movies? So I want to watch, it's $2 per movie, and I want to watch 10 movies. So I would plug in 10 to where n would be, plus $30. So it would be 2 times 10 movies, so $2 per movie, and I want to watch 10 of them. So it would be $2 times 10 plus 30 for the actual fee of the pass. So 2 times 10 equals 20, and plus 30 equals 50. So my first option would cost me $50. My next option is, let's see, $4, and I'd plug in 10 because still want to watch the same amount of movies. So 4 times 10 plus 10. So 4 times 10 gives me 40 plus 10 equals 50. So in this case, where I only want to watch 10 movies, it doesn't matter which pass I buy because it's going to give me the same price. It's still going to cost me $50 either way for 10 movies. However, Let's say I want to watch 25 movies or 50 movies. That's where the number can change. But in this particular case, you have to weigh out how many movies you want to see. So in this case, if I only want to watch 10 movies, it doesn't matter which pass I go get. So this part here, if I chose option A and watched 12 movies, what would you be billed? So option A was 2N plus 30, so $2 per movie plus $30 for the fee. And in this case, I want to watch 12 movies. So what I'm going to do is take my problem here, and instead of 10 that I used for the example, I'm going to plug in 12. So let's find out how much it's going to cost me. So 2 times 12 equals 24 plus 30 equals $54. It would cost me $54 if I took option A and watched 12 movies. The second part, if I chose option B and the company billed you $170, how could you figure out the number of movies that you watched? So in this case, we have to work backwards. So I'm going to break it down step by step. Option B was $4 per movie times the number of movies watched plus $10 for the fee. So let me plug this in. I'm just going to do this on a new slide so we can break it down. So the costs in total I spent was $170. So 170 equals $4 times the number of movies watched plus 10. So in order to figure out this problem, you have to work backwards. So I'm trying to figure out how many movies I've watched, which is my N. In order to do this is you take your numbers and you have to bring them to the other side of the equal sign. However, when you bring a number to the other side of an equal sign, you have to do the opposite operation. So if it was adding over here, I have to subtract it on this side. First of all, I do my outlier. So 4 times the number of movies, these are together right now. I'm not going to separate them quite yet. I'm going to do my plus 10 because that's the easiest thing for me to do first of all. You do your outlier. So I take 170 minus 10 because I do the opposite operation, and the opposite of addition is subtraction. So 170 minus 10 equals 4N, so 4 times the number of movies. So I'm doing this with that $170 fee. I take my $10 fee for the card itself or for the membership fee out. So that way it'll be easier for me to single out how many movies I've watched. So I have 160 equals 4N. Now, to figure out how many movies I watched, the only other number in this problem that I can use is the 4 because I can't put N on this side of the equal sign because I don't know what N is yet. So I have to use my 4. On this side of the equal sign, I was multiplying it. So if I bring it to this side, I do the opposite operation, which is division. So 160, I divide it by 4, and that's going to equal N. So I've managed to put N by itself, so I can figure out how many movies that I've watched. So now I do 160 divided by 4. So 160 divided by 4 gives me 40. 40 equals N. So if I got billed $170, it means I watched 40 movies. The best way to check to make sure you got it correct is to plug in your numbers and see if it equals. So I do 170 equals 4. Is 4. N is the number of movies I watched, so that was 40. So 4 times 40 plus 10. So I'm going to do my expression and see if this equals 170. So 170 equals 4 times 40 is 160 plus 10. 170 equals 170. They're the same, so I know it's good. And that's how you can check your answers. All right, this problem here. Student A started with $20 in the bank and deposited $4 a week. Student B started with $10 in the bank and deposited $6 per week. How many weeks did they have exactly the same amount of money? Solve in as many ways as possible. So the easiest way to do this is to basically plug it into an expression, and I can do an expression by plugging in different numbers and guessing, or I can put it into a chart. So in this case, let's make an expression and then we're going to put it into a chart. So student A started with $20 in the bank account and deposited $4 per week. So those are my numbers that I need to work with. She started with $20 in the account and she put in $4 per week. So plus 4. I don't know how many weeks she put in, so that's going to be my letter expression. So N represents the number of weeks because I don't know how many weeks she's been doing that for. So, but $20 was the starting amount. That $20 is going to be the outlier in this situation because I'm not multiplying that $20 by anything. It was already there, and now I'm just doing 4 times the number of weeks. So that's student A. Student B was $10 in the bank and deposited $6 per week. So in this case, it's $10 plus $6 times the number of weeks. I'm trying to figure out how long it takes for both of them to have the same amount of money. So I'm going to make a chart. Is A and B, and sorry, this is not going to be the neatest thing in the world. 6, 7, so N. So N is the number of weeks, and here's the number of weeks. So here's my expression is, for A, it's $20 plus 4 times the number of weeks. So I am plugging in this number into my N spot of the equation. So I have 20 plus 4 times 1, which equals 24. I'm going to try to make this a little neater. I do 20 plus 4 times 2 because now I have a 2 that I'm using. So let's say I put $4 in per week for 2 weeks. It'd be 4 times 2 plus $20 equals 28. 20 plus 4 times 3 equals 4 times 3 is 12 plus 20 is 32. And I have to do this bit by bit. Or, if you notice, I started with 24, 28, 32. I'm going up by 4 each time. So all I have to do is 20 plus 4 equals 28, 28 plus 4 equals 32, 32 plus 4 equals 36, 36 plus 4 equals 40, 40 plus 4 equals 44, 44 plus 4 equals 48. So it's a little bit of a life hack to make your expressions a little easier. So you're not doing this, you're not doing all the steps of that expression every single time. You just notice the pattern of what it's going up by each time. So that's student A. Student B is $10 plus $6 per week times, this will be 1 week. So this is 16. Now I have $10 plus 6 times 2 equals 12 plus 10 equals 24. Let's do another one. 10 plus 6 times 3 equals 6 times 3 is 18 plus 10 is 28. In this case, I'm also going up by 4 each time. So 16, or sorry, where did I go wrong? 16 and 10 plus 6 times 2, so 6 times 2 is 12. Oh, This is supposed to be 22. There we go. See? Even I make mistakes. Doesn't happen often, but it does happen sometimes. 10 plus 6 times 3. 6 times 3 is 18 plus 8. So in this case, I haven't found my pattern yet because this is 16, 22, 28. 10 plus 6 times 4. 6 times 4 is 24. Plus 10 is 34. So what number am I going up by? I'm going up by 6 over here, 6 over here, and 6 over here. So 34 plus 6 equals 40. 40 plus 6 equals 46. 46 plus 6 equals 52. So there are my numbers. Which weeks will both students have the same number of money in their accounts? Right off the bat, on week 3 for student B, I'm just going to highlight this in a different color. Week 3 for student B and week 2 for student A, they'll both have $28 in their accounts. Another time that it's happening is on week 5. They have the same number of money in their accounts on the same week. So on week 5, they're both going to have $40 in their account. And the question was asking, after how many weeks do they have exactly the same number? It was after 5 weeks. They both had the same number of money in their account. So that's my magical answer. And there we go. So your homework for this is going to be a bunch of simple algebraic expressions where you're figuring out your outlying number, or they're going to be some word problems pertaining to those, like the ones that we did here. And in our next lesson, we're hopefully going to be able to start using things like integers in our fraction, or in our algebraic expressions or our problems. This is something I do want to spend some time on. I want to make sure everyone's kind of good with this, because you're going to be doing a lot of it in grade 9 and grade 10, especially. Algebra is very heavy in high school, and I want to make sure you guys are good to go in terms of making your own expressions, but also figuring out the expressions. So how to balance out expressions to make sure they work, as in how do I find the solution to the problem, and then incorporating that with integers and fractions, which is also going to be really big in high school. So let me know if you have any questions whatsoever. I'm hoping you guys are going to do great with this because it is review from earlier in the year. But of course, I'm always here to help you guys out. Let me know if you have any questions. I can either send you an email writing out the answer, or I can send you a very short video. Just a reminder though, if you do want a video, more than happy to do it for you. You just might have to wait a little bit, because depending on at the time you email me, if I have my computer and pen tablet set up so that I can actually film a video right then and there, because it does take me a little bit of time to set them up. I'm hoping that the videos will be able to start being put up on the actual classroom page again. If not, it might just become a regular thing to post them on YouTube, just because the online classroom, it's become very difficult to upload videos onto it. So I'll let you guys know if that does happen. But otherwise, thank you guys. I hope you're having an absolutely great week, and I'll see you guys on Friday.